These next several slides will be covering section 3.2, which is about slope of the equation, slope of the line. So slope is usually measured in rise over run as a fraction. So your rise would be here and your run would be here. And that's typically denoted as m. M equals slope, and that's your rise over run. So let's look at this particular line. I wish it would have given you a different problem to begin with. Let's go to this one actually. So let's consider the slope of this line. So for example, it's easiest if you can find, go from an intercept to an intercept, or go from one point that's very clearly a point to another. So in this case, actually pretty much every jump is actually a point. Sometimes you might get something where it's going to go up more like this. So in that case, you've got a point here, and then you wouldn't have another nice clear point until here. And then you would have another one about here. So either way, it helps if you get some points that are nice on grid lines so that you know that it's an exact point. So back to the original one, what we want to do is go from any one point to any other point. It really doesn't matter which one's which, just so long as you stay consistent. So let's pick this point and this point. So our first point here is x equals 0 and y equals -2. And then our next point is x equals 2, y equals 0. So your slope is going to be up 2 and then over 2. So it's 2 over 2 or 1. So our slope equals 1. And we'll talk about the actual points a little bit further. Let's go back to that negative line now. So now, again, remember I was suggesting that you find a solid point. So this is actually a great example of that because I don't see anything here that's a solid point until you get to this intercept. And then keep following the line, looking for your next solid point, and it looks like it's about here. So I'm going to measure between these 2 points right here. So we've got 1, 2, 3, 4 down. So we're going to make that a -4 and over 1, 2, 3, over 3. You want to pay attention to which one of these you make negative. It doesn't really matter as long as you stay consistent. So this isn't quite a good example because here we're definitely going down. Actually, I guess you could do it if, let's say you went up to here. The next point I think would be right about here. So let's say you went up. Let's go ahead and measure that one instead. We're going to go up 1, 2, 3, 4. So we went up +4, and now we're going over 1, 2, 3 to the negative side. So we're going -3. So you can see either way we end up with a slope of -4/3. Now let's look at one last one. Again, try to find a clear point. So we've got our y-intercept is a clear point here. And if I keep going down, it looks like this one is also a clear point. So let's go ahead and calculate that rise over run again. We can do down 1, 2, 3 over 1, 2, 3, 4, 5. So that's -3/5. Or if you want to see it the other way, like I said, it really doesn't matter which way you go. Just stay consistent about it. So now we're going up 1, 2, 3, and over 1, 2, 3, 4, 5. We're going to the -5. So either way, slope is -3/5. Now, what happens in this case? So it's got our 2 points laid out for us. So let's go ahead and count these. Are we going up at all? No. So our rise is 0, and then we're going over 1, 2, 3. So we're going over a +3. 0 divided by 3 is 0. This is perfectly fine. anytime you have a horizontal line, your slope m is going to be equal to 0. Now the tricky case is this next one. Now we have a vertical line. Our rise in this example is 2, and our run is 0. This is not allowed. We do not want a 0 in the denominator. This is what's called undefined. So for a vertical line, the slope m is undefined. And then here's just a synopsis of our slopes that we can possibly have. We can have a positive slope. That means as you go in the positive direction on x, you're going in a positive direction on y. We can have a negative, which means if you're going positive x, you're going negative y values. You can have your 0 slope, which was your horizontal line, and we can have an undefined slope, which is your vertical line. So here's what I was trying to do at the very beginning that I realized was too early. So when you've got your 2 points, you can use what's called the slope formula. And that formula is the change in y. Here, let me write it the way it's written sometimes. Change in y over the change in x. And that's also if you take your y2 minus your y1 over your x2 minus your x1. It doesn't matter which one you assign as x1 and y1, and x2 and y2, just be consistent. So if you want this point to be x1, y1, that's perfectly fine. And if you want this point to be x2, y2, that's okay as well. You're going to get the same answer. Just stay consistent with whichever one you choose. I'm going to go ahead and use the ones that they've already labeled for us. So let's calculate the slope in this for this one. So we've got m equals the change in y over the change in x, which is y2 minus y1 over x2 minus x1. So our y2 is 6. Sometimes you'll want to go ahead and put these in parentheses, especially if it's a negative. In this case, we don't have any negatives, but this is the most common mistake I see, is where somebody puts a negative here, and then this next number is not a negative when it should have been. So if you can, get in the habit of going ahead and putting those, the y2, y1, x2, x1s in parentheses. That'll help you eliminate any of these negative sign errors. So let's continue. So we've got our y2, which is 6. Our y1 is 3. And that's going to be over our x2, which is 7. And our x1, which is 2. So now we've got 6 minus 3 is going to leave us 3. And 7 minus 2 is going to give us 5. And then let's go ahead and check this. So we've got a rise, 1, 2, 3, check. And a run, 1, 2, 3, 4, 5. Awesome. So that matches exactly what we found using the points. So here's another example. You've got your rise of 1 and your run of 2. And that is going to give you this equation. This is slope-intercept form. That's what that equation is called. We're going to look at it a little bit further here and here. So if you remember, it said y equals 1/2 x plus 3. Here's your slope and your intercept. And you can see it more clearly right here that that's your intercept, because if you plug in x equals 0, this goes away and all you're left with is this. So that would give you a 0 and a 3 and your slope right there. So here's it broken down all at once, all together. And then when you're being asked to graph a line, here are some possible ways to graph it. So they might give you an equation, let's say 3x plus 2y equals 7. In this case, it's easier to use point plotting, probably. Yeah, I think that would be easier to use point plotting. So you could say, okay, well, when x equals 0, y would have to equal what? So that 2 times y equals 7. So that's going to be 3.5 or 3.5. So you get the idea. And then you could do y equals 0, and then what would 3 have to be to make 3 times something equals 7? So you would just go ahead and fill in those points, and then pick one more. Maybe another one, easy one, is when x equals 1. What would y have to be? So that's an example of using a point plotting. Slope-intercept form, to graph this one, you could just plot your intercept. So actually it says right there, start at the y-intercept and then count the slope. So let's say our intercept was here, and our slope said it was up to over 3. So it would be positive 2, negative 3. And then we could just rewrite that. Y equals negative 2/3. And then let's say this is 3 plus 3. The intercepts, to graph it with the intercepts, that's also easy if you have a y equals mx plus b, or even if you have something like this, you would just end up doing these points. And then recognizing vertical or horizontal lines. So let's say we had x equals 3. How would you graph that one? So what you could do is you could imagine any point. So here's 1, 2, 3. X equals 3 here, x equals 3 here, x equals 3 here, x equals 3 here. That's going to give you your vertical line. Or let's say we had y equals negative 2. So here is y equals negative 2, y equals negative 2, y equals negative 2. So our graph is going to be that horizontal line. And the last couple things we're going to be covering in this section are parallel lines. So if you think back about when we're calculating the slope, what do you notice about both of these lines here? They have the same exact slope. So let's say this is y equals 2, 2/5 x plus 3, and this one's y equals 2/5 x minus 2. So you can see they have the exact same slope, so these are considered parallel. These are also considered parallel, but we're not going to see this in the slope, because this is going to be just x equals 2 and x equals 5. And the last one that we're going to be talking about is perpendicular. So sometimes it's denoted like this. Sometimes it's also called orthogonal, but I don't see that very often in this book. But just in case you ever come across that word as well, it's either perpendicular or orthogonal. And the interesting part about this is, what do you see about the slopes for each of those lines? So sometimes it's denoted with the little square here to indicate that that's a 90-degree angle. In this case, it doesn't denote that, but it's definitely a 90-degree angle, so they're definitely perpendicular lines. So the slope might be easier to see if you write it with the 1 underneath. So we've got our first line is y equals negative 4/1 x plus 2. And then the next line is y equals 1/4 x minus 1. So we're focusing in on the slope here. And do you notice that they're similar? It's called a negative reciprocal or a negative inverse. So the one slope was negative 4. A negative inverse or negative reciprocal slope is going to be a positive 1/4 instead of a negative 4/1. So for example, let's say we had a slope, let's say we had y equals 3x plus 5. What would our perpendicular slope be? What would our perpendicular line be? In this case, it would be y equals negative 1/3 x plus, let's just say plus b. Let me do one more example. Let's say we've got y equals 1/7 x plus 3. Our perpendicular line would be y equals negative 7x plus b. So I hope you're seeing that that's just the negative inverse of whatever the original one is. That's to indicate a perpendicular line, perpendicular lines. And that's it for this section.